is, for this class, it is Tuesday, July 23rd, from 10:30 to noon, in this room. In this room. Okay, so you show up here, I hand it out to you, you take it, hand it back. Yeah.
I have a question about the quizzes, the ones we have to take in the testing center.
Arithmetic proficiency?
Yeah, if we took it twice and failed it, what do we need to do? I emailed you, but I'm not sure.
Yeah, I had a few technical difficulties with my email here recently. In fact, may have, depending on when you did it, it may have bounced and I may never get the email. But here's what you do. The very first thing you do is if you go in and check. I had a student in my office this morning, and we were looking. They'd got a 60%, and they said, I've reviewed it, and I'm convinced that I put the correct answer. And we looked, and it was true. That moved her from a 60 to a 70, and so if you can do that with either of the two versions that you took, find one that is correct, then you've passed that one. Now, if you had a 50 and you only find one that you think is right, that's not going to help anyway. But so if you find that there aren't any that you got right that it marked wrong, your next thing is to go into the arithmetic proficiency quiz folder, which is right under the course information folder, and inside of it you'll find one. You'll find a file called Additional Practice. Okay, Additional Practice for Arithmetic Proficiency Quizzes, and it tells you exactly what you need to do in there. It's basically you get this little program, practice a bunch on it. I've had a student already do this for they've missed two of them. They've done it. And they came in and they got 10s on after practicing in this thing. So anybody in that boat for any of the first four or the fifth one. The fifth one's due this Friday, right? Okay. Yes?
I have a question about the personal resource.
Okay.
Is it due like at midnight or is it due at next class? Like, you know?
I think I just got it up there. It's as you've noticed, we're at the end of the sets and numbers unit. I thought I had opened this a little earlier, but the testing center, it says it'll open next Monday and next Wednesday. Is that going to work for you while we continue on to the next unit, or do you want to bump it up a little earlier? I'll see if the testing center could accommodate. That's the date I set at the beginning of the semester, but I either got off or... So I've got it right now scheduled to open next Monday, a week from today, close Wednesday. Is that going to work, or do you want to? Would you rather move it up? So the personal resource would then be due sometime before you go take it, which at the very latest would be 9 p.m. on Wednesday of next week. Okay? Does that make sense? Okay. You'll also notice that I have put in to the grade book, I've put in your grades for the exam. And if you don't like the score you got for your exam, come on, what's going on here? If you don't like the score you got for your exam, in the course information folder, the very last item, there's a file called Test Repentance Policy. Okay? And you can go read what my test repentance policy is. It's my way of you raising your test score up. Okay, so go check that out, and something is crazy. What other questions?
Okay, so with the arithmetic quizzes, if you failed them once, do you still need to buy the computer program
If you failed them once,
and haven't retaken it?
unless it's number 5, it's all those the deadline's over. So you do have to go purchase the thing.
Okay,
Yep.
and all of them are due Friday? Or just we have to get through them at least once by Friday?
Most of you will have passed all 5 of them by Friday. My absolute latest deadline is July 5th at 5 p.m. So you go purchase this program, you work. It'd be nice if you came in next week and got them done.
Yeah.
But my absolute deadline is, in fact, I will know those students that have to repeat the course. It's kind of crazy to repeat this course because you didn't pass one quiz. It's really crazy. But if you don't pass them, and that's my deadline, so I want those all finished up.
And how many is the maximum amount of time you can retake it? Twice?
Twice in the testing center by the deadline, and then you go practice, and then you come to my office and I give you on paper, you'll be right there and you'll take it right there.
Okay.
If you buy the program, I have never had anybody not pass and do what I've asked you to do in it. So
How much is the program?
it's been around $8.50, but who?
It's like $12.
What?
It's like $12.
12? Is it up to $12?
Could we share with someone, like the program, and that's like the cost of the 2 of us or something?
Then I have no way of knowing what practice you've done and what practice they've done because you register with your, you know what I'm saying?
Yeah.
So that's the problem with that. So you say, yeah, I've practiced, and I guess I could say, okay, if you've practiced and you don't pass my paper exam, then you're, you know what I'm saying?
So that's the final.
Yeah. But, yeah, another question.
Oh, so, sorry.
I do that all the time.
If you do the program, will it make you go over all of them?
It has 5 different practice quizzes, so you only need to practice the ones that you weren't successful with.
Oh, okay.
So if you just missed 3 or just 3 and 4, and you passed 1, 2, and 5, just practice 3 and 4, and those are the only ones I'm going to make you retake.
Okay.
Okay? Yes.
Okay, so I'm reading your test repetitive thing and I still don't understand.
Okay, reread it then. Okay? Reread it. I'd be happy to talk about it, but I've tried to write it in a way that and give you some examples. Look at the examples and see, do I even fit? Do I even qualify for it? You know, if you've got a 96% already on the test, it doesn't apply to you, as you'll see as you read it. But
Are all the test scores in?
how about yours? And it's because you didn't take it at the same time everybody else did. And I've got it here, and I was trying to throw it in, and for some reason it's not taking it on this. Yeah. I'll have it in for the days out.
Okay.
Yeah, sorry about that.
Did you say when we have to have the reflections thing in to?
The reflections, in order to get the feedback, is this Friday at 1 p.m.
Okay, because in the iLearn it's like October.
Isn't it saying that?
Yeah.
It's like October. It's like.
What?
I thought it was what it said last time. It's June.
What does it say?
This morning, though.
Yeah, mine said June 7th. Maybe June 7th.
Okay. Okay. let's move to questions about the quiz. Anybody have questions on those fractional converting? Do we need to look at converting that one repeating into a, Chris?
Yeah, can you do, like I understand with the repeating decimals and how to get it into a fraction, as long as like the repeating decimals, like the very first, so if it's like your example on the test was 232323, I understand that one. But
You don't have problems unless,
it's like 3 and then a repeating 5757. I don't understand how to do that.
okay, so you'd like to review how to do, give me the one you just had.
Okay, so like the 35757, like that one? And then
With the 5-7, okay. So that's the one you're having trouble with.
Yes.
Is anybody having trouble with the one on the quiz? Would like to see it? You'd like to see it. And it was what?
0.23.
0.23 with a bar over the 2 and the 3?
Yeah.
Okay. Invitation for a couple of people to come up and work these two.
I can do this.
You can do this one. We'll let you come do this one if you're, okay? Who can do the ones, you know that? Okay. And anything else from the quiz? Did you have all those other ones memorized and you went through them really fast so you had plenty of time to work on this one here?
I can't remember how you set it up, but I just remember it was equal to 99x, and then you would just divide it by 99.
Where did you get the 99 from?
I don't remember how you explained it, that's just how I've been doing it, and it works. But, like, because you set it equal to 100.
The original problem we set equal to x.
Yeah.
And then
So
we
this
do
was
what?
equal to x. Oh, and then you multiplied it by 100.
You count the number of digits in the
Repetition.
repetend. There are
You
two,
go
so
over
you
to
multiply by the second power of. That procedure will always make it so that your repeating part cancels when you subtract.
Yeah.
That's how you get rid of it.
The part that would confuse me is sometimes I thought, oh, there's 3 numbers and then it starts repeating, so I have to move these all over to the other side of the decimal, but you don't. You only move it twice, and then you leave, even though this is a repeating one, you still leave it to the right side. And then you can just multiply like both of these by 5 to get this number to be a whole number. I don't know what that is off the top of my head, but you multiply both by 5.
Okay?
Yep.
Let's do it. What's 35.4? Actually, here's an easier one. Multiply by 10. Because that's easy to do in your head. We get 354 over 990, and then reduce it. And we know it's even, so that's going to be what? Half of 4 what? 495. And half of this is 177. Is that as low as it'll go? Is 177 prime? Yeah, 3. So 3 goes into there 5, 9, right? 3 goes into there 1, 6, 5. 59's prime, right? And 165 is not divisible by 59, so that should be it. Grab your calculator, check it. Did we get this when we... This is the method I taught you. In the homework I explained a different way where you could you can actually multiply these two by different amounts, and then you don't end up with a decimal ever, but it's just easy to remember to multiply both sides by the same number. For me it is. but you're welcome to use that other method.
Where'd the 35.4 come from? How did I get that?
When we took x equals our original, got our two decimal places, multiplied both sides by 100, we got 100x here. So when we subtract that, we get the 99x. And here, when I multiply this by 100, that moves the decimal 2 places. So that's 35 point what? 7575757. Okay? And then these cancel to 0, all zeros, and then here's my 4 and then my 35 when I subtract.
Oh.
Okay? Anybody else? Let's move from the quiz to the skill practice test. Anybody have anything on there that they did not?
On it, it says that like it was due today at 10:15, but it's still letting you like retake.
Huh,
Can we retake it still?
you shouldn't after today,
That's
but you could have retaken it as many times as you wanted to up to the deadline. Yeah. Question?
Yeah, can you show us how to do, like, base 10 to base 4?
Base 10 to base 4 conversion,
Or
or any base 10 to another base is what you're saying. How many of you would like to see this or practice this or, yeah. Any base to base 10 is always easy. It's way easy if you understand. Let's just do one of those real quick. Let's do 4, 7, 5 in base 8, and I want to turn it to base 10. These are the easy ones. What do? I write this in expanded notation. So 4 times, and I like to do it from the other side. 5 times 8 to the zeros place plus 7 times 8 to the first plus 4 times 8 to the second. It's actually kind of turned around, right? The values, but I like to start here and then I know how many places I end up with. And then I just grab a calculator if you want and punch that in. And that is the answer. But going the other direction is not quite so easy. So let's take one. And base 10. Let's do 4,657 in base 10, and we want to turn it into base 8. Who feels comfortable enough if they came to the board and you can tell the people at their seat what you need to calculate? Do you want to try? Come up and try it. If you need a computation, just say, find this for me, and they can punch it in for you.
Okay, so the first thing I do is I figure out what the highest amount, like 8 to the 4th is 4,096. So that can go into that. 8 to the 5th, it can't. So I know I have to start at 8 to the 4th. So then I subtract
And how many 4,096s are there in there?
1.
There's 1.
So you put a 1 there. And then you subtract. And then you get 561. And 8 to the 3rd is 512. So that only goes once. So you put a 1. And then you subtract. And then you get 49. And then 8 squared is 64, so obviously 49 can't go into 64, so it's 0.
There aren't any 64s in 49.
So then 8 to the first. I just do it on my calculator so I don't mess up. So 8 to the first, 8 to the first. And it can go 1, 2, 3, 4, 5, 6 times. And then you get 48. And then you have 1 left and 1.
Where'd she get the 48 from? 6 eighths went into 49, right? So 6 times 8 is 48.
You're done.
Okay? Then you could, if you wanted to, kind of double check it, go 1 times 8 to the 4th plus 1 times 8 to the 3rd plus 0 times 8 to the 2nd plus 6 times 8 to the 1st plus 1 times 8 to the 0 and hit enter, and you better get the original number we started with. Does that make sense? Okay? Good question. Is that helpful?
Yeah, I think I did it right. I think I just did my math wrong.
Yeah. That's why, you get up into these big numbers, and calculators are nice. And you will be allowed, again, to use calculators on your exam. But I want to see I want to see this kind of work going there. Okay? Did you have a question, Devin?
Could we go over how to find fractions between fractions?
Fractions between fractions.
So it says find the fraction that is halfway between 2/3 and 5/7. I think is
Okay? Let's even do one that's, if we do one a teeny bit more difficult, if you can handle that, you should be able to handle anything, right? So, what two fractions do we want to find them between?
Do you want one off of the?
I don't care. What we can do, let's do 3/5 and 8/9, and we want to find the fraction that is, should we say 2/3 of the way?
Okay.
2/3 of the way from this to this. How do you do that?
Add the two fractions together. First you gotta get the denominators the same, but then add them together and then multiply it by 2/3.
Why does that work?
I have no idea, I just know it works.
Where'd you get it?
One of my math friends taught that to me. So
Okay. Recently?
Yeah.
Okay. Yeah.
Oh, I was thinking because out doesn't any multiplication.
What?
Doesn't the word out mean multiplication? So
When we're talking about fractions, yeah.
So
But 2/3 of some number would be 2/3 times that number. But this is 2/3 of the way from.
I have a question.
Yeah.
Do you have to find a common denominator? Because on the practice test, I don't think I did. I just added them and divided by 2, and I still got it.
If you're after the number halfway between, that method will work. So you didn't need to find a. But here's a method that will work every time. Are you ready? What you do is you want to find how far apart these two are. If it was on a number line, what's the distance? Right? So how do you do that? How do you find out how far apart they are? You subtract them, right? The little one from the big one. So let's do that. 8/9 minus 3/5. What do we get? Well, in order to subtract, we're going to learn in this unit, we what? Get a common denominator. So that's going to be what? 45, since they are relatively prime. It's just going to be their product. And 40 and 27. So I've got what? They're 13/45 apart. Right? That's the distance from there to there. Now what? We want to find 2/3 of that distance. How do I do that? Times it by 2/3. Somebody says with fractions, you want 2/3 of that. So we take 2/3 times 13/45. That gives us 26/135. Is that correct? That is, so that fraction is that much of this distance. So if I were to start here and go up 2/3, I've gone up 2/3 of that distance. But that's added on to the 3/5. Does that make sense? So if I'm at 3/5 and I go this much more, that's where I'll be, because this is 2/3 of that distance. Does that make sense? Let me do it this way. What's 2/3 of the distance from 6 to 9? Well, how far is it from 6 to 9? 3. So if I've got 6 here, and I've got 9 here, the distance is 3. Well, this distance right here is 13/45. Now, if I want 2/3 of that distance, what's 2/3 of 3? 2. So that means I'm going to go up 2 from there. So I'm going to go 6 plus 2 is 8. 8 is the number that is 2/3 of the way from 6 to 9. Does that make any sense? So we've done the same thing here. I subtracted 9 minus 6 and got 3. Then I took 2/3 of 3 and that was 2, and I added 2 onto the 6. So I subtracted, that's the distance from there to there. I want to only go 2/3 of that distance, so I go this far, but I'm going from where? From 3/5. So I go 3/5 plus 26/135, and the answer that I get will be what I'm after. And we'll need to get this turned into a common denominator with that in order for it to work. Let's do it. What do I have to multiply 5 by to get it to turn into 135? 27. So if I multiply this by 27, I've got to multiply the top by 27. That gives me 81 plus 26/135 is 107/135. That fraction is 2/3 of the way from 3/5 to 8/9. Okay? Do you agree with me? We could turn this into 135. What times 5? 27, right? So that's 81. And 8/9 is, let's see, be times by 15, right? 8 times 15 is what? 120/135. And I'm claiming that 107 out of 135 is 2/3 of the way to there? To go from 81 to 120 is how far? How many?
39.
39, right? From there to there is go 39. And if I divide that into 3 parts, I get 13, and 2 of those parts is 26. So 26 onto 81 is 108. You following me? That's about as hard a one as you'll ever get. When you're doing halves, it's pretty easy. You can average them, like you used an average method.
How come you have to add it to the 3/5 again?
Because I found a distance, and I don't want to go the full distance. I only want to go 2/3 of that distance. So I found 2/3 of the distance, but that's not the number I'm after. That's how far I've got to go in that distance. So if I'm starting at 3/5, I've got to add that on.
Okay, that makes sense.
Okay? Anybody else want to ask a question? Again, the density property says there are an infinite number of numbers between 3/5 and 8/9. And you could find 2/3 of the way, or you could find 3/5 of the way, or whatever. Okay? Anything else?
In the glossary, we have to define closure. What do you mean by closure?
We didn't talk about that. Let's talk about closure. That becomes more important in the next 2 units, but closure is an idea. The idea is super important for elementary teachers. The idea. The name, knowing that it's called closure isn't probably as important as, but I have heard so many students, or so many teachers, elementary teachers, where in, say, 2nd grade, they'll say, the student, they'll say subtract 7 from 23. And they'll go, they'll hear the teacher say subtract 7 from 23, but they'll write this. Okay? Is that correct? It's not what the teacher said, right? But here's what the teacher says to them. She'll say, you can't subtract the big number from the little number. Can't you? I can. What is it? Negative 16, right? Yes, you can. Well, but you hear it all the time. You can't do it. Or the teacher will say, when divide 24 by 8, and they'll go, that's not what the teacher said. The teacher meant the other way around. And the teacher will say, you can't divide the big number into the little number. Well, of course you can. You get 1/3. 24 goes into 8 1/3 of a time. Right? What did the teacher really mean? Or what should she have said?
She should have said no, flip with, or like, she should have explained like what she meant as far as like when she says it. So like, she should have said, okay, the last number I say you want to write first, and then.
Oh, so you'd help her rewrite it so that it was written correctly, and then there wouldn't be any and you'd go 24 divided by 8. Okay.
Yeah.
But what about this other problem? The teacher's saying this. So the student does this. The teacher says, you can't subtract the big one from the little one. What does the teacher mean? What the teacher really means is, but you don't want to tell students that because it's a lie. It is. You can. But the teacher doesn't want to confuse the student. what the teacher should probably say is, for the number systems, the number sets that we know now, we don't know how to get that answer. You understand what I'm saying? Closure. It has to do with two things. You have to talk a set, and you have to talk an operation. So, let's talk the set of counting numbers, and let's talk the operation addition. In order to be closed, this set, the counting numbers, to be closed under this operation, you have to be able to pick in the set and grab any two counting numbers. They could be the same one, actually. And then I have to operate on them. If the answer I get always comes out of the same set that I pulled out of, we say that the set of natural numbers is closed under addition. Is it? If I grab a counting number and add a counting number to it, do I always get a counting number? Will I? Is there any way not to? Can anybody think of a... Okay, so then the counting number set is closed under addition. Let's try subtraction. The counting numbers. I pick any counting number I want, any other counting number, and I subtract. No. Here's a counterexample, right? I got something other than a counting number. I got a what? An integer. So we say that the set of counting numbers is not closed. We don't say it's open. We say it's not closed under subtraction. Okay? And I think what the teacher meant here with this problem is, if we take the counting numbers and we use the operation of division, do we always get a counting number? No. What kind of number is this? Rational. So we would say the counting number set is not closed under division. Is it closed under multiplication? Is the counting numbers, are they closed? Is that set closed under? Yes. No matter what counting number I multiply by whatever other counting number, I'll always get a counting number. So the idea of closure is you have to talk set and operation, and if you pick two numbers out of the set and operate on it, and you get an answer, always get an answer that's in the set that you're talking about, then that set is closed under that operation. If you can't get a number in that set, or if you end up getting a number not in that set, if it's possible to not get a number, you say it's not closed. Okay? Thank you. I maybe ought to swing that one over into the next unit, but you'll have it. This here is your assignment, the beginnings of your assignment for tomorrow or Wednesday. Here's what I want to do. Everyone has to do all of it, but tomorrow we're going to have some presentations on